listening to the Virtual CISO podcast, providing the best insight on information security and security IT advice to business leaders everywhere.
Hey there, and welcome to yet another episode of the Virtual CISO podcast. With you, as always, John Verry, your host, and with me today, Tim Mackey. Hey, Tim.
Hey, John.
How are you today?
I'm doing well.
Yeah, you told me it's the end of the day, not to expect your A game is sort of like what you said when we were warming up here, right?
Yeah, it's almost beer o'clock, so we're fine.
and anyone who's a listener to the podcast knows I never bring my A game, so we should be matched up pretty well. Always start easy. Tell us a little bit about who you are and what is it that you do every day.
So I have the glorious title of being head of software supply chain risk strategy at Synopsys. So that's a mouthful, and eventually I'll be able to have it like roll off the tongue quite nicely. But it's basically a reflection of the work that I've been doing for the last 2 years that, for practical purposes, started when President Biden issued his executive order on cybersecurity and said, hey, gee whiz, but we need to get better at this, folks, and I'm going to start wielding some pretty big sticks. And that itself was an outgrowth of the architecture product security roles that I've had in the past. Long history with open source going back a couple decades. The grays come through honest grief. So just have fun with software and find interesting ways to communicate the risks that are inside of software.
And I hope they pay you by the letter for your job title, because if not, that's what you should negotiate next time.
So I once had a bio read at a conference by the big voice that does the BAFTAs, and I really want to somehow get the recording of that, because someone in their infinite wisdom put my entire bio, which is like 3 paragraphs long, and the poor gentleman had to read the whole thing.
Yeah, there's nothing worse than having, like I always tell people, give me the shortest bio you possibly can. Here's a moderately intelligent guy to talk about information security. Boom. That's a good bio.
I do stuff and things with security.
Yeah, exactly. I think that's probably the most accurate bio you could have. So you mentioned it's beer o'clock. What kind? What's your drink of choice?
So right now it's more of an Eagle Rare.
Ooh, Eagle Rare 10, 17. Okay, have you found a bottle of the 17?
No, I have not.
It is a unicorn bourbon. I found one bottle. I've been drinking bourbons for about a dozen years. In that entire time, I found one bottle, and I gave it to a friend as a gift, which I regret to some extent.
No, every now and again I end up over in Ireland or over in Scotland, and I will try and find something that you can't get in the U.S. and bring that back.
Yeah, there's some great Irish whiskeys.
Yep.
There's some great Irish whiskeys. So you and I could definitely enjoy a drink together then. So you mentioned software security, which is what we're here to chat about. And, anyone that's in this space has probably heard the term software bill of materials more in the last year than they have in the previous decade, or SBOM, right? I mean, that term, I think, originated around 2010, but it's certainly escalated. So can we start simple? Define what an SBOM is, please.
This is a really, really important definition point, because there are lots of people who are running around saying, oh, I need an SBOM. I want an SBOM. It's somehow magical because everybody's talking about it. And what they don't realize is that an SBOM is quite simply a list of the dependencies that a piece of software has on something else. And that could be a piece of open source. That could be a commercial third-party library. That could be an internal library. Technically speaking, you could extend it out to also include things like data providers. So it gives a view of the world as to what this piece of software needs in order to function, or how it was built using, well, basically supply chain elements.
Yeah, one thing, it occurred to me the other day when I was chatting with someone that they really didn't understand that concept of what an SBOM is about, right? So when you think about it, I'm a terribly bad Python programmer, but I like to play around sometimes. And I might so let's say I wanted to just every day go down to go to a particular website and download a table, do a little data processing on that table and send myself an email, right? Simple little task that you might do. I could probably do that in 50 to 100 lines of code. However, I would, I would import pandas. I would import beautiful soup. So despite the fact that I'm writing an application with 50 lines of code, I might be connecting that with libraries or packages, whichever term the different languages use, that have tens of thousands or 100,000s of lines of code in them, right? I mean, that's the thing that I don't think people who are not programmers fully understand.
I would completely agree with that. And Python's a good example of a modern language that, for practical purposes, you don't have to worry about a lot of functionality. You can worry about what makes your thing unique. Node.js is another good example. We can go into Rust. We can go into Golang. For practical purposes, all of these languages and all these frameworks have allowed us to do very quick innovation. These are the things where you don't have to think about, well, how do I secure a web page? Well, there's a library that worries about that for me. How do I actually listen for a web request? Well, there's a library that does that for me. How do I go and parse the strings and bring out all of the parameters? Well, there's a library for that. Now I need to save it to a database. Well, there's a dozen libraries for that. And very quickly, you can get yourself into the hundreds, if not thousands of libraries, depending on the type of application that you're creating. And the reality is, from a security perspective, all of the design decisions, all of the testing decisions that those libraries had, well, they're not the same as what your code has. But if they're bad, your code is going to fall victim to it somehow, some way.
Yeah, that's the crazy thing, right? I can write 50 lines of perfect code, but I'm relying on 10,000 lines of code in libraries that I don't know what was done there that might be vulnerable. Hence, I have a vulnerable application. Okay, cool. Because I was talking with the guy and he just wasn't fully getting it, and I said that to him and he just kind of went. I could see lights go on. So this SBOM thing has become like everywhere, omnipresent.
And in fact, I blame President Biden for it.
That was what I was just going to ask you. Let's talk about what is driving that interest, right? Why are we here talking about SBOMs?
So, a couple reasons. First and foremost, if we have an executive order from a president that suddenly uses technical terms and uses them kind of correctly, this should be our opportunity to pay attention. Whoever the ghostwriter was, and I have some pretty good ideas as to who the ghostwriter was, did a fantastic job of educating the world on the types of risks that could be within a software supply chain. And they used examples like SolarWinds and Kaseya and CodeCov and so forth. These are all things that, well, you quite honestly don't expect a U.S. president to know anything about, independent of whatever their background might be. Like this is something where you go and have people go and worry about it underneath the covers. That forced everyone to go and say, oh, wait a minute, SBOM appears 38 times in this document. That's an obtuse amount of reference to SBOM. I need to pay attention to it, which meant that a lot of software security companies reinvented themselves overnight. Zero Trust was also mentioned in the executive order, so all of the network security companies suddenly became Zero Trust companies overnight because, well, we're going to attach to this. And the reality is, the executive order did nothing more than say, heads of agencies, here's some problems, go think about them and tell everyone how you're going to fix it. So NIST and NTIA and OMB and all of the alphabet soup that is the government. That suddenly brought it into the public's frame of reference. But for practical purposes, what got lost in the shuffle is that there is no single SBOM. There are different pieces of data that are important in different scenarios. So we even have SBOM being referenced in the omnibus bill back in December. So a spending bill has an SBOM reference in it because they decided that they were going to modify the FDA's regulations to require an SBOM, vulnerability disclosures and vulnerability informations with any new pre-market filing. That's different than what President Biden was talking about, but it's all related. And so as people start to connect this SBOM concept into some real requirement, they're forced to actually start asking the question of, well, what can I do with this thing? What is it really going to enable me to do better, faster, stronger?
Yeah, talk a little bit about, so, one of the things that the presidential executive order did as well, is he directed, if you will, the NIST to come up with an approach to this, right? So they came up with, what we would commonly refer to as the SSDF, or Secure Software Development Framework, and it was documented in NIST Special Publication 800-218. Talk a little bit about the SSDF and how that interplays, if you will, with SBOMs.
So the SSDF existed before the presidential executive order, but it needed to be revised as a result of the executive order. And effectively what it does is it sets out some outlines for how you might prepare an organization to start doing secure development, how you would go and do the types of testing that are going to be necessary, do vulnerability response, and effectively say, here I am going to create a piece of software and it's going to be adherent to some level of security acumen that is going to be defined by NIST. Whether you follow NIST or you don't follow NIST, at least here's a rubric for success. One element in the SSDF is an SBOM. So without having an SBOM, you can't go and claim that you're performing all of the various tasks inside of the SSDF. And the SSDF is quite expansive in its expectations. It includes things like how you might go and construct a CI pipeline, or how you should secure developer environments, the use of multi-factor with source control systems, the types of testing that you need to perform depending on the type of application, how you're going to have separation of release artifacts from test results so that you can avoid scenarios like SolarWinds where things came together in unfortunate ways. So the fact that this SSDF framework exists is effectively a baseline for how organizations who might not necessarily be following all of these elements can actually mature into becoming more secure development organizations in a reasonable period of time.
Right. Probably fair to say the SSDF is more akin to a good recipe for a good software development lifecycle, and of which one component of that would be a generation of an SBOM.
Exactly.
Perfect. So, like you mentioned, it would be pretty easy for a complex application to have dozens, hundreds, maybe even thousands of different libraries and dependencies. So, generating an SBOM manually, while it is, I guess, possible, would probably be all right. Maybe it's not possible.
Oh no!
I mean, it's possible. Possible, but painful.
For a specific reason.
Okay.
The number of SBOMs that I've seen that are in a CSV file that someone is manually editing the contents of in Excel is shocking.
I know. I've seen them too, and I don't trust them as far as I can throw them, right? It's because how are you going to actually maintain that? How are you going to So while you can do them manually, I think most organizations are starting to recognize that using something referred to as a software composition analysis, or SCA tool, is a better approach. So can you explain how an SCA tool works?
Sure. And as disclosure to everyone, I came to Synopsys by way of the Black Duck acquisition.
Oh, did you? So you're the perfect person to talk about this.
So SCA stands for Software Composition Analysis, and it's effectively going to take a look at one of two things: either the source code and identify all of the libraries that are included as dependencies, either directly or indirectly, or it's going to take a look at a binary and perform the same task. Obviously, if you have access to the source code, you're going to have a greater level of accuracy in the results than if you've got a binary and you kind of have to guess as to whether you've got component 1.1 component version 1.1.1 versus 1.1.2. They might be a little bit fuzzier in terms of being able to identify that sort of thing. But fundamentally, it's looking at what exactly are the list of dependencies for the application. Creates a bill of materials, and then underneath the covers, it's going to map that bill of materials back to a knowledge source of some form that is typically representative of all of the activity that's happened in the land of open source. So you get, I've used OpenSSL 1.0.1J, and I really shouldn't be using J. I should be on something newer. Then you start to marry in security information from the National Vulnerability Database, and you can get a bit of a picture as to what the security governance practices are within a development organization when it comes to open source.
Okay. So there's value there's a dual-facing value to an SBOM. One, there's value to me as the developer, the company producing the software, and then there's going to be value to the people that are receiving the SBOM. Let's talk about the value to me as a developer. What is that value?
So as a developer, the first thing you really want to do is make certain that you're choosing components that are properly maintained, that don't have any outstanding security issues, and that whose license actually aligns with whatever your organization says is the correct set of licenses to use. And so that can get into the reciprocity of code and whether or not, for example, the organization expects to go and publish all of the source code or not. So simple governance, answer for the license compliance side of the equation. You can set policies to say, well, you know what, I shouldn't be using a library that hasn't been maintained in 3 years.
So that would be, oh, sorry about that. Keep going.
No, or a library that has outstanding unpatched vulnerabilities in. So basically, give me something that's new. It's not like 6 versions behind, because if you needed to update that, if you get too far behind, you're effectively taking a whole lot of functional changes that you might not expect just to, say, patch a CVE.
Yeah, so when I've been in like the Black Duck software user interface, right, you guys break down 3 types of risks, right? Vulnerabilities, licensing, and operational. So you were giving examples of each of those 3 types of risk, I believe, there.
Exactly. And there are different types of risks that you can overlay on top of it. But fundamentally, it's a case of how do you do risk mitigation? And if I'm a developer, I might want to have that in my IDE so that I know that, hey, this component is good. And my canonical example from the Node.js world is, do I like buffer, safe, buffer, safer, buffer, or safest buffer?
I'm guessing safest.
Actually, you probably want safe buffer because it's more recently maintained.
But it's got an S at the end. That has to be the best choice.
Exactly.
I mean, Tim, that was a trick question.
Now, the real interesting question, John, is how many different versions of that do you have? Do you have all 4 of them in your application? And you might actually have all 4 if you don't know where things came from.
Yeah, that's interesting. And so vulnerabilities, I think for anyone listening, are pretty easy to understand. That's poorly written code that it is likely to lead to an exploit of the application because the library is vulnerable. You talked about operational. I think that's fairly easy to understand. That would be where maybe this library is no longer being maintained, or maybe the community is a very, very small community, and you might say, should I count on something where I've got a library that's being maintained by a single individual and it hasn't been touched in 2 years, right? That would be an operational risk, right? And you'd say, I might be better off finding a different library there. Licensing is one that I always get a little confused by. So can you explain what licensing risk is?
So all software has some form of license associated with it, series of rights and obligations. And within an open source space, the rights usually include things like I can use this in any type of application that I want, and I'm free to do a bunch of things with it. It's the obligation side of the equation that starts to get a little bit funky for most people. So contrary to popular belief, just because it's on the internet doesn't mean it's free. There is, in fact, a set of rules, and one of the rules could be that if you incorporate my software into your product, you have to go and publish not just a copyright of mine or an attribution back to me, but potentially the entire source code that is associated with what I've now become part of. So publish the entire source code of the application. For some organizations, that's exactly okay, and the world moves on, and this is not a problem. But for other organizations, that's a bridge too far. They want to retain access to their intellectual property, so they don't want to be publishing the source code. So the license that I may have put, that more restrictive license, means that maybe for that organization, my code, as good as it is the wrong code for them. It just doesn't fit their worldview. And so it is quite simply a set of, you can almost think of them as contractual requirements of, here's a set of rights that I'm granted, here's a set of obligations, are the various elements compatible with each other now across all of the dependencies that are in the application so that there's no encumbrance on the end result.
So that effectively keeps you out of legal issues, right? So we're helping people with security issues, legal issues, and operational issues.
Exactly.
Okay. So we talked about the value to the person creating the software. Let's talk about the value to the person receiving the SBOM, or in a best case, a digital SBOM. So what would be the value to the person receiving it?
So the question is less about what's in the SBOM, because the SBOM itself has limited information. It's got the list of dependencies, and it may have license information, and that's it. Vulnerability information is another document that's related to it. So the way I like to think about it is an SBOM is an enabling technology. It forms an anchor point to say this is what this application looked like at the point of its release. Now you have a vulnerability data feed that's beside it. You can have attestations, conformance statements, data flows, API endpoints. All of these things could now be mapped into the SBOM in a way that allows for someone who's on the receiving end to go and answer important questions like, well, how well tested was this application? Can I use it in an environment that might be highly critical, say a banking application or some form of critical infrastructure? Was it actually designed by people who are within the realm of people that I can do business with? So when you start dealing with governmental scenarios, you might have scary companies or scary countries or scary individuals that shouldn't be contributing code to this type of application. So you can start to do a lot of analysis around what's happening in that application and the type of security practices that are employed by the entity that is producing that SBOM and that software. Obviously, you can go and bring it into a larger system to do some continuous monitoring for new vulnerability disclosures and make that part of an overall patch management effort. But in terms of the how well suited is this application to run in my environment with my context, that's something that you can really do well when you have an SBOM that is what I tend to refer to as robust, because that's how the FDA defines it, and is truly comprehensive and accurate.
So let's say that I'm the CISO of a bank, and I've got thousands of applications in my application inventory, and let's say I was lucky enough that all of those applications provided me with a digital SBOM so that I knew all of the individual components within those applications. Talk a little bit about how Log4j might have looked a little bit different for those poor guys.
So I can tell you exactly how it would have been different. You would have been able to know with a simple query which applications had Log4Shell exposure, including all of the version spray that happened while the Log4Shell experience was being solved. Then you could have had a proactive ticket both to the internal development teams, but also a proactive outreach to all of the suppliers to say what was the mitigation put in place. What are your plans for remediation of this? What are your timelines? And actually had a very engaged process behind it. So effectively shortening the time to identification from being, say, couple weeks where you're querying everybody in the organization as to, well, tell me the status of your application, all the way down to maybe an hour or two for identification, and then the remediation time taking however long it needed to take.
Right. Yeah, to me, that's where, and I know it's going to be a while before we can get to that kind of a point, but to me as a security practitioner, that's when I look at and say that would be exciting, that somebody would have instantaneous access to understanding where the risk is. They can put their own compensating control mechanisms in place if they need to. They can be proactive in reaching out to the vendors. Yeah, it would have made life a lot less of a fire drill for a lot of people.
And the interesting thing is that at that point in time, we had one customer who had basically bought into our full story around how you should do things with respect to SBOMs. And they were able to identify within their client base, they were essentially a managed service provider, all of the impacted Log4j installations, all the applications, fix all of them, produce a blog post and a video in less time than it took most people to wake up from their slumber that morning.
That's really cool.
And it's like, I only found out about the blog post maybe 3 or 4 days later. It's like, yes, this is the way it's supposed to be.
Yeah. Just as a someone who lives, eats, and breathes this every day, how long do you think it'll be before we approach that level as an industry? Is it it's certainly years. Is it more than years?
I think it's going to come on us very quickly. And I think we're going to be somewhere in the next 24 months, maybe as short as 18, maybe as long as 36, but not much longer than that, that most enterprise level organizations, so let's say your mid-sized businesses and higher, will be operating with an SBOM-centric mindset for their application procurement and governance. And partly that's going to be because, well, we had the Biden-Harris cybersecurity strategy from a week or so ago that said that, well, the U.S. government is going to use its purchasing power to kind of up-level the AppSec and overall security and cyber capabilities of their suppliers, which when you start looking at how that nests out, very quickly you end up with almost the entirety of the U.S. software producers encompassed. So I think we're 2 years.
Wow. I hope you're right. Should SBOM generation be something that is baked into an organization's development pipelines?
Yes, categorically. It should be something that is, in fact, I would say that we should think of it as multiple phases of SBOM. So the developers need to have their SBOM. We need to have something that represents the packaging side of the equation, and we need to have something that represents the running state. And now you can actually start to say, this is the set of changes that the development team are producing. I want to make certain that my operations teams understand the implications of those changes. And if I need to do a quick patch for something, so let's say I need to swap out log4j, and I'm just going to do that in the VM or in the container image itself because it's just the easy way to swap it out, I can actually say, my running instance is this. However, I know that I have a development dependency to go fix that. So I can, at least in the operations side, accelerate remediation or accelerate mitigation.
So I'm not sure I fully understand. So we've got the developers, right? Yep. And obviously what we're trying to do with the developers is make sure they're not writing vulnerable code and make sure that they're, as early as possible, making good decisions about the components, the libraries that we're using. And
those decisions are going to impact the people who are running the software.
Right. So when you say packagers, define packagers, because you said, I just want to make sure I followed the train. You had developers,
so packages
then you
being
had packagers.
The libraries that developers bringing in to make the application work.
Oh, you said packages, not packagers.
Yes, packages.
Oh, sorry. I thought you said packagers, and I thought it was a term that I wasn't
familiar
with.
No, sorry.
Okay.
I will blame the internet for that.
That and my ears would be fair to blame as well. And then... So on the operations side, what we're trying to do is they would use that same software bill of materials to know what their responsibilities are going to be in operations. Is that so that they can plan accordingly?
Partly, but also to give them an opportunity to say, hey, wait a minute, you've changed the risk profile of this application. I can't accept this because. And here's an example of how that can play out. So let's say, for the sake of argument, that we've got a web application. And somebody has this wonderful idea to ensure that there's a spell checker in that web application. And so the developer goes and finds a fantastic spell checking thing that is powered by ChatGPT or some other AI system. The initial implementation says, sure, I'm just going to put it in these couple of areas. The world works fine. We're happy. Then somebody else decides that it would be a fantastic idea if that was applied to everything so that we can have proper spell checking. What they didn't realize was that the security questions, the responses were now also being sent over to this cloud service because they were being spell checked. What are the ramifications of that to the operations team? They now have a data leakage issue. So if there's a way for them to know that there's a set of changes in here that will not be acceptable for whatever governance reason, ideally the developers know that beforehand, but we've all seen non-functional requirements that are of the compliance issue that you have the rework. So we're never going to solve that problem completely. But if we have the ability for that SBOM during its development lifecycle to also be communicated over to the operations team, they have a fighting chance of saying, wait a minute, this doesn't make any sense to me. We can't run this.
So it's sort of a belt and suspenders when threat modeling, risk assessment doesn't work the way that it's supposed to.
Yeah, and so we effectively end up creating a little bit more of a
closed loop.
And, and so then when we start doing some tabletops, we can say, wait a minute, this thing here, well, I need to go and mitigate that because we've made a change as a result of maybe a legitimate requirement, maybe a regulatory requirement, or maybe it was just a product owner who said, hey, this looks really cool, we need to do this.
That's pretty cool. I didn't think of that.
Yeah, and so this is really one of these things where as we go through this SBOM world, today we always think about it in terms of, hey, I can understand open source vulnerabilities. But the real challenge is to start saying, well, if I don't use the word open source and I don't use the word vulnerability, what other kinds of things can I do if I only knew what was inside this software?
Mm-hmm. And just to be clear, right, open source or non-open source, commercial libraries, right, the SBOM situation is still the same, right?
Exactly.
And because we've talked open source quite a bit, and I don't want people to just get left with the idea that SBOM is only about open source libraries, right? It's about any library that we're using, any component we're using.
Correct. It's literally anything that we have a dependency on. Okay. And so the way I like to look at it is it's open source, it's commercial third-party libraries, it's contracted software, because who knows what the practices are within the development shop that you're contracting. It could also be APIs and anything else where there's a dependency.
I was just going to ask you that, right? An API is something that would be part of an SBOM, right? If you're reliant on a particular API or set of APIs.
Today, it's not part of the specification, but once you start saying, let's remove open source from the table and say what else we can do, you can very quickly end up in a position where you're starting to ask these questions. And if nothing else, you want to create the opportunity to have a mapping of here's my APIs and the data flows that are going out of the APIs. Here's my SBOM. What component is actually doing that? What component is supporting that traffic flow? Because as an example, there might be a phone home mechanism you didn't know about.
Mm-hmm. Makes sense. We covered everything. We beat it up pretty good. Anything we missed? Anything you want to close with?
So the only thing that I want to say, just as an SBOM journey kind of experience, is that there's an awful lot of tools out there that will generate SBOMs. There are far fewer ones that generate SBOMs that are adherent to either of the SPDX or CycloneDX specification. Mm-hmm. We're very much in a garbage in, garbage out mode. So the first order of business, I would say, for anyone who's starting down this SBOM path is when you pick your favorite SBOM generation tool, and there are many to choose from, take its output, take it over to the respective validator tools that are created by the SPDX or the CycloneDX community, and see if it's a valid SBOM. If it isn't, move on to the next tool. Just don't even bother trying. Move on to the next tool, because you're going to invest more time trying to make the tool work when you should be worrying about how you actually go and do the analysis of the software that you've got to generate a legitimate SBOM.
Right. You don't need more work than the tool's already going to kick off for you.
Yeah.
Because you're going to find, if you've never run Black Duck software before, it's gonna give you some work to do, because it's gonna find some things that are wrong. And the last thing you need is you're trying to sit there and manipulate a digital SBOM to get it to be, that it can be read by your customers. I mean, actually, if you really think about it, you can invest in this software, and you're investing in this software, in large part to satisfy client demand. And then when you hand off the SBOM, if it's unreadable, you've got an unhappy client and you haven't met their demand.
Exactly.
Yeah.
So,
and you've been modest. Just to be very clear, a reminder: Tim works with Synopsys. Synopsys purchased Black Duck software. Black Duck software is probably the longest tenured organization in the software composition analysis space, and Synopsys's tools are best in class, right? I mean, if you look at all of the Gartner Magic Quadrants and Forrester Waves and everything of that nature, Synopsys sort of stands alone up in that upper, clear differentiator. Arguably, I think easily arguable, probably the best software application testing company in the world. Between your software composition analysis tools, your Coverity SaaS tool, White Hat DAS tool, and I'm missing one. What's the other one? IAST Seeker.
Seeker and
yeah,
which for fuzzing.
Yeah. So yeah, I mean, it's a great portfolio of tools that work together in a nice way. So cool. So hopefully you did your homework. You look confident, so I think you did. Give me a fictional character, a real world person you think would make an amazing or horrible CISO, or if you prefer, software developer, head of software, something like that.
So my horrible CISO, my horrible software developer would be Tony Stark.
I don't know.
He is so not a team player.
I mean, Penny would disagree, I think. Well, Penny would probably agree. All righty. If folks want to get in touch with you or with Synopsys to talk about Black Duck software?
Synopsys.com. I am at Tim in Tech on Twitter, much as we still use Twitter. And the Synopsys Twitter account is at Synopsys. Spelled with a Y, not an I.
Okay. And Tim in Tech, is there an H on the tech?
There's an H on the tech. So CH.
All right. Sounds good, man. Well, listen, this was fun. Thank you for coming on. I appreciate it.
Thank you, John.